Hello. So, hello everyone. Today is the week 8 of our uh, TA-ship and tutorial session of cellular biophysics and framework for quantitative biology. So today I'll mostly discuss about one topic he has been discussed in the main lecture series, that is about Python programming and how to do Python, and I'll go through the programming session one by one. So for Python program I will use Jupyter Lite or Jupyter Notebook. So you can just search Jupyter in your Jupyter Notebook in your browser and it will come up to be like this, Jupyter, and you can try Jupyter in your browser and go to Jupyter Lite and it will show up like this. So if you open your Jupyter Notebook, you will have your saved notebooks in the left hand side, and you can open a new notebook from like here, and it says launcher, and in launcher like here also it is there, and there are different kinds of environments you can use. You can just go to Python and here you will see how to write code. So I'll eventually go from basics to, at last we will solve for Turing patterns. So I'll explain how to solve these Turing patterns and get this kind of plots in Python. So first one will be how to write Python code. So if you just simply write, let's say 2 plus 3 and enter run here, or control enter or command enter, you will see it gives the answer. So basic operations you can do directly in the console of Jupyter Notebook or any kind of Python setup you are using. One more thing I would like to say, that like in this boxes you can have code or markdown option. So in markdown option it supports LaTeX equation. So if you know about LaTeX, you can write it like this with $2 signs. So it gives you alpha sign. So any kind of equations you can write, but you have to change this from code to markdown. Like to add a new cell you can add here, or you can from here you can add also. So for code, Python code, like for the very first Python code people write is the hello world. So in Python, if you want to print something in the console, you write like this. So print suggests, so it will print it on the terminal or it on the console, and in the inverted comma you write hello world. So it will print hello world. So again you can write print anything, like print, let's say hi, and it will print. So it helps you see some like variables. Let's say you assign a variable, let's say variable 1, you assign it to 39. So it does nothing happens, right? So there is no output here. To see what the variable 1 value is, if you do this, like print variable 1, you will see the assigned value is 39. So one by one I'll go through some basic features of Python. So what our plan will be, first will be, let's say basics of Python, basics of NumPy, basics of, sorry, it's not DumpY, it's NumPy, basics of matplotlib. So this matplotlib helps you to, this is for the arrays, array operations and manipulations, and matplotlib it's for the plotting. and lastly we'll solve a PDE, that is reaction diffusion equation or Turing pattern, and that will be your goal to solve a PDE and see how from a basic some kind of initial condition how we can generate Turing like patterns, which we have already discussed in the last session. So here let's start with arrays. So to install NumPy, NumPy is a library that helps you manipulate arrays. So we'll see some example, like NumPy can do almost everything you will want to do with an array, like let's say to sum two arrays, to take products, dot product, cross products, all those stuff, to invert an array, to have calculate trace of an array, to calculate determinant of an matrix, everything you can do using NumPy. So to install NumPy, you should run this command pip install NumPy. So if you run it, it will automatically install it. If you have it already, you don't need to install NumPy. So after you have installed NumPy, you have to import it in your code. So if you don't import any kind of library, you have to import it first. So this is one of the very important mistakes people often do, which is you should always install or import the libraries you want to use at the beginning of your code. Also do not import unnecessary libraries. It slows down your code. So let's say you just want to use NumPy, so you don't need to import matplotlib. So if you don't want to plot anything, you don't want to import it. If you want to import just NumPy, then just install NumPy. So I hope it's visible. Let me zoom it in like this. Okay, run it. Now if you run it, so it says so to comment something, so this you start with hash in the code environment. With hash, if you start it, so it would not read it. It's just for the comments of the user. So if you want to write what is exactly happening in these lines or in these lines, you will write it with a hash in front of it. Now if you like this said import NumPy as NP. So what does this NP means? This NP stands is something you assign. So instead of writing NumPy every time, you can just use the short form NP. So you can write anything. You can write your name, anyone's name. NumPy, you import NumPy in the standard form because NP kind of looks like NumPy, so you know it is the NumPy environment, NumPy library you are doing. Now what is this? So print, we have already said. So print is like string NumPy version np dot underscore version underscore. This will show which NumPy version you are in. So if you run it, you see this is the output. So it means NumPy version 1.26.4. this is the NumPy version of the NumPy that is right now installed in your system. Now if you don't have NumPy installed, you will not see anything. This is not necessary always for code, just to see if it is there or not for these specific cases. So that was our step 1, installing and importing NumPy. Next is step 2 is creating arrays. So how do you create arrays? So you can create some different arrays, built-in functions from the, I'll eventually show. So this is how you assign an array, assign a variable to an array, which is you can have anything. So this is a 1D array which has just 1 2 3 4 5. These are the data. So you write np.array. Remember we just said that NumPy as np. So if you could have written NumPy.array to like shorten our time, like shorten our code writing time. We just use np.array. Any library you use, you have to write this library's name dot some function built in that library. You have it follows. So name of the library dot, that is this, followed by the function or inbuilt by the inbuilt function name is the syntax for calling the array, calling the function. So NumPy has an inbuilt function which is array, which takes inputs as inside this third bracket or square braces, and NumPy.array starts with first braces. So how do you know? If you like, you don't have to remember anything, remember this stuff, you just Google it. So NumPy array, if you just search it, you can go to NumPy creating arrays, NumPy. So this is the NumPy manual. So NumPy.array has all these kinds of options: object, d type, copy, order. So everything you can, this documentation you can go ahead and look into, and you will know what kind of options you get to use this NumPy.array. Now if you want to see what this variable array has been assigned to, you can just print np.array and it shows this 1 2 3 4 5. If you had changed something, let's say you made it 10, you see this becomes 10. So anything, like you can assign minus something also. So 1 2 you can, this array arr variable has this array loaded inside. Now what about 2D array? 2D array are like 2D matrices which have lists of lists. So these are called lists. So you see this is a list, comma, this is another list, and the whole thing is inside another list. So if you see a square braces, you know this is a list. So 1 2 3 4 5 6. So np.array. So if you print this 2D array, you see 1 2 3 4 5 6. So this is the array. So you can change anything here. So if you change it to this also, you see NumPy array operations. So now how to access, and like let's talk about array operations. So let's say you want to add two arrays, like element wise addition. So you have 1 2 3 one array, 4 5 6 in another array. You want to have the sum, array 1 plus array 2. So how will you do it? So you just write array 1 plus array 2. So what will be the answer? 5 7 9. Now if you run it, you see it has printed for this line, it has printed array 1 is 1 2 3, array 2 is 4 5 6, and then result of the addition. So print this string result of the addition, comma, result. So this is how you print and string and number. So let me write this comment. This is how you print a string. String means it's just some words. It does not have any value assigned. Like even if you write this inside, it would not show, it just show array 1 instead of a value of the array 1 which it has shown in here 1 2 3. It just shows arr1. It's just, it reads it. If you put inverted commas like this, quote marks, it just reads arr1 as arr1. It does not go to its value. But if you write it here, it takes the value that you have assigned in here. So this is how you print a string and a array slash number together. Okay, so this is what you have got. So this is how you sum two arrays. Next is scalar multiplication. So if you want to multiply this some array with a scalar number, let's say 2 3 4 5 or anything, you just write star that number and you will get the multiplication. So similar way we are plotting. So 1 2 3 was our actual array, we are doubling it. So original array is 1 2 3 and doubled array is 2 4 6. Like if you multiply it with, let's say, -1, you get -1 -2 -3. It is as simple as that. Okay. So next is array indexing and slicing. So what do you mean by array indexing and what do you mean by array slicing? So let's say you want to let's say you have an array like this, 10 20 30 40 50. Now you want to know which element you want to access a particular element. So how will you have that? So for that, okay, let me just go to the Google Meet and hold on. So sorry, so let's say you have an array like 10 20 like this. Sorry, you have 10 20 30 40 50 like this, 10 20 30 40 50. Now indexing, so this is the array and every array has an index assigned to it. So every array has an index assigned to it. What is this index means? Index corresponds to the which element you are talking to. Like if you, okay, hold on, let me write it not here but properly. So I will write it here. So this is visible. So let's say you have an array 1 is defined as 10 20 30 40 50. Now every array has an index assigned to its elements. So what does it mean? So these are the array elements. These are numbers 10 20 30 40 50. It could have been anything, and every array index of this array, every element of this array has an index assigned, like at which position they are in, index assigned. So in Python, this index starts from 0 and goes to the number itself. Like number itself means, like for here this case, the index are 0, 1, 2, 3, 4. So we have 5 elements and index are 0 to 4. These are the index. So this is an important concept of Python, where the index starts from 0. Okay, so let's say, so what will be the second element? So if you want to print which element in this array corresponds to the index number 2, so you count 10, 20, 30. So it is 0, 1, 2. So this first one should be 30. So element at index 2 is 30. Now let's say what is the index at element 0. You see, element at index 2 is 0. Oh, sorry, not 2, here it will be 0. So element at index 0 is array 0, which is 10. So it is 10. What will be this one? What will be 50? 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4. So if you put 4, let's say 4, it has 50. Now let's say if you put something else, like if you put 5, so will it show anything? See, it says index error. So this is a very common error you will get when you write big codes, which is index error. So what does it mean? So you are trying to assign an element which is bigger than this matrix. So you are saying, give me the 5th element of this array, but it has only 0 to 4. Like essentially this 5 means you are trying to achieve an index which is not there in that array. So it will give you error. So always, one more tip is, always read your errors. Errors tell you a lot of interesting things. So line by line it shows the error. So it says the first line does not have any problem, this line also does not have any problem. Here you get an error. What is it? So in this line you got this error. So you said negative in no, not this index error. Index 5 is out of bound for axis 0 with size 5. So this means it is out of bounds of this index. Also, now the moment I change it to anything from 0 to 4, it shows perfectly. Also in Python you have negative index. So whenever you put a negative index, it starts to looking at this array from the end to end, starts from the end, and it goes back towards the first. So let's say you want to see what the -1th index is. So -1 index is says 50. So this is 0, 1, 2, 3, 4. Also this is -1, -2, -3, -4, -5. So that's why array -1 shows 50, array -2 shows 40, array -2 shows 40. So let's just come here. So also here we also have -1, -2, -3, -4, -5. So this is another indexing in this in Python. So sometimes you don't want to go from the front, you just need the last element. So for any given array, the last element is that array -1. So this is how you just achieve the last array. Next is slicing. So let's say you want to have only these three elements. So how do you reach it? So this is from index 1 to index 4 or index 3. So remember 0 1 2 3 4. So now if you want only say that print array 1 to 4, index 1 to index 4, what does it mean? So index 1 2 3 4, so it will print 20 to 50. You see 20 30, sorry it is not 3, it's 4. Okay, so array minus 2 to, so whenever you don't want to specify the rest of it, like you want to say the all of it, so you just do minus 2 all. So not minus 2, minus 2 suggests that elements from last, second last to last, so second last to last. This is just the different way of achieving. So there are multiple ways of doing the same thing. So this same you can have from 1 2 3 4, 0 1 2 3 4, let's say 0 to 5, you get all of them. So whenever you write it like this, it goes from 0 to n minus 1. So if you write 4, it will go to 3. So 0 1 2 3. So to achieve the last one, you will have 0 to 5. So 5 means it will go to 0, from 0 to n minus 1. So here n is 5, so it goes till 4. So 0 to 4. So 0 to 4 is the whole matrix. Okay. So if you want to have from index number 1 to 5, 1 to index number 4, you write 1 to 5. So 20 30 40 50. Fine. So this is how you index and slice a matrix in NumPy environment. Okay, so same way in 2D array you can have, like let's say 10 20 30 40 50 60 70 80 90. So here let's write it down again, 10 20 in matrix form, 40 50 60 70 80 90. So this is, let's say we have this matrix and this is 0 1 2 0 1 2. So in this 10 will be index 0 comma 0, this will be 2 comma 1, so sorry 1 comma 2. So it's always row comma column. So you write it like this. So what will be, let's say 2 comma 1. So 2 comma 1, what is 2 comma 1? Let's see if it gives correctly or not. In our case 2 comma 1 is 80. So let's write here print add 2d, sorry 2 comma 1. Let's put it in bracket comma, and to have the same thing, right? 2 comma 1, so is 80. So you see 2 comma 1, we also checked this 2 comma 1 to be 80. So anything also you can have it like this. Also it also 2D arrays also support this negative index. So minus 1 comma minus 2 is also 80. So 2 comma 1 and minus 1 comma minus 2 is also 18. So if you can have look, like you can play around with this and have different setups and check if your concept is kind of matching with the one the code gives or not. Next is array properties. Now you can like check for a given array some properties, let's say shape, size, and what are the data types. So that syntax is for is dot array dot shape. So this arr is your array. Now if you just write arr dot shape, it will show shape. Shape is, see, 1 2 3 4 5 6, but with in it is 3 columns and 2 rows only. So this way it is columns and these are the rows. So it has shape is 2 comma 3. Size is total number of elements, so there are 6 numbers of elements, and data type is int 32. So int means integer, these are integer data type. So this is how you can check the properties of an array. Next, you can actually reshape arrays. So let's say you have 1 2 3 4 5 6. You want to reshape these arrays in a 2 comma 3 matrix. So what is the question here is, let's say I have given you one 1D array 1 2 3 4 5 6. This is an 1D array. Now I ask you, reshape this array to a 2 cross 3 matrix. That means 2 rows, 3 columns. So you do it with the numpy with this function reshape. Now if you do reshape and you assign this reshaped array to this variable which is reshaped array and 2 comma 3, and you get this output. Original array is this, reshaped array is 1 2 3 4 5 6. Now you could have done 3 comma 2 also, let's say. See, now you get 3 rows and 2 columns, 3 rows and 2 columns. Okay, remember you can only reshape it to the if the total number of elements stays same. Like you can't reshape a 6 element matrix to a 3 cross 3. For a 3 cross 3 matrix you need 9 elements, but you don't have 9 elements. So that's what, so you say, it says cannot reshape array to subsize 6 into shape 3 comma 3. Fine. Now array transpose you can also do. Now the whatever you have got the reshaped is a 2D matrix, you take transpose and you get this 1 3 5 2 4 6. So I hope everyone knows the meaning of transpose. One thing is, one very important thing next is random number generation. So how do you generate random numbers? Random numbers are actually random numbers, so they don't have any correlation. Correlation means, like, for a given number you don't know what the next number is, you cannot know the next number is. That is why they are called random number. They don't have any memory of what the previous number is. So this is how you generate random number, if via NP. So this, what it does is it generates a random number array of 3 comma 3 elements, and the numbers will be between 0 to 1. So 3 by 3 array with numbers 0 to 1. So this is the random number generator array it will create. Here it creates these random integers of size 2 comma 3, and the limit is from 0 to 10. Actually this is 0 to 10 minus 1, I guess. So it creates integers. So this one does not create integers. This one creates a real or floating point number between 0 to 1, but rand_int creates integer random numbers, but integer between some value 10 to some n1 to n2. Okay, so this is how you create random numbers. Next is aggregation function. So what is this? You can have sum of this array element, mean of this array element, max of this array element, mean of this, like minimum number of array elements. So here you can, if you write the sum of all these arrays, you can directly get the sum. Now mean or average of this array elements, you can have mean just like you don't have to add everything and divide it. manually, you can just write sum or mean like this. You can have the maximum of these elements, which is 50, which is this. It is printed 50, and minimum is 10, and which is it shows. So these are the features of this array elements. Now one more very important is how to save and load arrays. So let's say you have an array 1 2 3 4 5. Now you want to save this array in your computer. So to do that, you just do np.save. So what np.save does, you give an num and name of this data file you want to store with a particular extension. It can be anything, npy or any kind of data file. You can give a name to it, and you have this comma arr means this comma variable name, so it will save. So I think np.array only supports a .npy extension. There are other ways to save a file also. Now if you run this, you see here, sorry, let me zoom out. So here there will be a my array. See, my array.npy, I have given it to here, and it has created. Let's delete this. So there is no my array.npy right now. Now the moment I run this, you see there will be my array.npy generated here. Why does not it generate? Let me refresh it. So let's call this, and here, see, after running this my array.npy, so it is some kind of npy, it is some binary function it has written, but it understands, the numpy understands. Now this you can actually load from the same directory. If you like, if it is saved in this directory, and you can load this, and you can assign this same variable here. Now this loaded array, now if you print loaded array, it says 1 2 3 4 5. So what is happening in this 4 line is, you create an array 1 2 3 4 5, assign it to some variable. Now you write this variable name to numpy array saved array. Now you load this numpy array and assign it to another variable, and see if it has loaded the correct value or not. So original array was 1 2 3 4 5, and loaded array is also 1 2 3 4 5. Lastly, I would like to point out about this thing, which is matrix operations. So let's say you want to have dot product up to these two matrices. Dot product means it's like essentially we have product, like so one matrix 1 2 3 4, and another is 5 6 7 8, right? So if you just do a product 19, so you do like this, right? 22 15 plus 28 18 plus 32. The answer should be like this. So this is the cross one, 19 22, you see 19 22 43 and 50. So this is how you get the product. So there are multiple of things you can do with numpy. So this Jupyter file I will share with you in the Google Drive that has been shared with you with all the PDFs, and if you go to numpy here, you can have a look at all the functions. Like it has a lot of options, sorry, here. So here all the array creation routines, numpy entry, numpy I is the 1001 matrix in identity matrix. So all lots of stuff you can actually look at and do whenever it is necessary for your problem you want to solve. Okay, so that will be numpy. And next I will, so numpy, so basics of Python, basics of numpy array operation is done. Now basics of matplotlib. So now let's say you want to plot a variable. So how will you do it? Let's go here. Okay, hold on. So okay, so next point will be another very important library that I will discuss, that is matplotlib. So the same way you do import this matplotlib. If you don't have it, you just pip install matplotlib. So you import matplotlib.pyplot as plt. So now again, this is matplotlib.pyplot is the library, and you are importing it as plt. So wherever you are writing, you will write plt dot something. Okay. So you are importing this here, and also to assign arrays we are importing numpy also. So this has installed. Now let's start plotting. So let's say we define an array 0 1 2 3 4 5 x array, x axis, and y axis. In y axis let's have y square. This is y square, sorry, x square. So y equals x square we want to plot. So you see, this is how the plots is. Now let's say we don't put anything here. So plt.plot essentially plots this, but in Jupyter notebook it's showing this one. If you are doing something else, you wouldn't see anything until you say plt.show. Now what is plt.show? Plt.show assures that you want to see this, otherwise it will just plot it and there will be nothing in the forefront. So you should always never forget plt.show. Never forget plt.show. Now it is showing properly. Now you can see this is 1 2 3 4 5. So 0 1 2 3 4, and you have x versus y. Now you want to put labels in x axis, y axis. So if you want to put a title of this plot, so you write this plt.title with inverted comma. So this is basic line plot. If let's say it's so it shows basic line plot. Now if you want to give axis name, you say the x axis, and y level it is y axis. So this is how you plot your first plot. Now there are lots of customization available via matplotlib. I will show some of them. First is, let's say with the same plot. Okay, let me show you. Let's say instead of this you wrote y star y. Does it work? I don't know. It does not work. Y. Okay. Anyway, we should have used np.array. That would have worked. So now the same two variables, you write plt.plot xy. Instead of just xy, now you say color is red. Now if you show color is red, you see this color has become red. Now there is line style, so dash dash, this is dash dash. Now you show marker is this circles, and this is marker size. Now what about these colors? Now if you go matplotlib and google.pyplot colors, so go to the first link, you see plt.colors. So these are the inbuilt colors. So you can either write blue, brown, pink, this, or BGRC, C for cyan, M for magenta. Let's try to change it to something else. Let's try to put C, cyan. See, this has become cyan. So markers, now anything you can just Google, like let's say dash means just the same line. There should be dash dot. Yes, see that dash dot. O, instead of O, I think you can use stars, hash. No, hash is not there, or what? Let's check. Hash. Okay, hash is not supported. So again you can do matplotlib markers. You see, these are the list of markers. V, triangle left. Let's put this. Let's put something crazy. So okay, so let's put this dollar alpha. Oh, it does not show anything. F. Okay, marker shows this F. Okay, so let's put P. Oh, see, if you increase the size, marker size, let's make it 20. You see, instead of, oh nice, so instead of any marker you can have any alphabet also. See, QQ. Oh nice, it shows QQ also. So this you got. Now again, customize line plot x-axis also plt.grid. What is this grid? This grid is a background thing, so there is no grid, it's plain. Now if you plot it, you have a grid. So grid true, you have to write true here. Okay, now let's say you want to have multiple plots on the same figure. Now for same x value you have y1 which is 149 and y2, let's not make it the same, let's make it cube, 2764. Now let's see, this is y equals, let me make it x cube. Now this blue line corresponds to y equals x square, this green line corresponds to y equals x cube. Now you can have this kind of legend, so this is the legend, and to have this legend, to specify which is what, you write this legend here, label, this is label, and to show this label you have to put this legend. So if you do not put it, see there is no legends coming up, though you have put labels here. So although you have put labels here, if you don't put legend, if you do not get this legend. So let me put it this one, even if you put label in plt.plot, if you do not write this, you not the legends will not show up. Okay, so this is plt.legend and at last plt.show. So this is how you get multiple plot. Let's say y3 you want to have, which is y1 plus y2. Okay, now here you do plt.plot x comma y3, label is y equals x square plus x cube, let's put color equals m, that is for magenta. Does it show anything? Why does it give error? Print y3, let's check. Okay, oops. Okay, so this plus is not correct, so that is why we need np.array. So np.array will be better, because here now Python array, what it does is it just adds it towards end, to one another's end. That's why it did not show the correct value. Now if you use np.array properly adds these two arrays. Okay, so now you see these two words there. Okay, so that is there. Now let's have subplots. Now let's say here you want to do not want to plot the two lines on the same plot, so you want to have subplots in one figure. you want to have multiple subplots. Okay, so let's say these two you have x and y1 y2. Now you want to put x square, this first plot, in one subplot, second plot in another subplot. So you do it right, instead of plot you write plt dot subplot, and 1 comma 2 comma 1 is row, column and index. So you want to have a 1 cross 2 subplot, so 1 row 2 column subplot. Now in the first index of this first place of this subplot you want to put plt dot plot x comma y1. So this y1 you want to put in the first one, and similarly 1 comma 2 comma 2 you want to put it here. So tight layout is for adjust the spacing between subplots. Now if you don't put it, what do you get? You don't see much, but for multiple plots you will see what exactly this kind of extra things does. Okay, next is bar charts. So you all know what is bar chart is. Bar chart is this kind of plot. So this also you can do. Let's say you have categories A, B, C, D, and every category has some kind of values assigned to it. Let's say A has 3, B has 7, C has 2, D has 5, like this. Now if you just plt dot bar categories versus values, so categories versus values, you get this color, and you put this color blue, and any color you want to put. Let's say K is for black. Now you have this bar chart, and rest you know already, title, x level, y level, plt dot show, everything. So this is how you plot bar chart. Then you have histogram. So now let's say this is very important. So you create 1000 random numbers between 0 to 1, and this is rand n. So rand n is picks random number from a normal distribution. So what does it mean? So if you, let's come here again. So what is a normal distribution? What is a normal distribution? So normal distribution is, let me check, is, so you have, let's say, some random numbers, list of random numbers, some, let's say, n numbers of random numbers. Now the probability distribution of this random so distribution. Okay, so let me give you an example and that will be clearer. Let's say instead of plt.hist, let's say you don't do any histogram, you do plt.plot data. Let's try to plot this data. You see, this is how this data looks like. So it does not follow any kind of any function, like it is, like for example, it does not follow any of this kind of, like for pattern, like for, if let's say it did follow y equals x square like pattern, then for a given value you can tell the next value is, let's say I see its x is 0 1 2 3 4 5 and this third element is 4, then you can say that it next will be 9 because it will be 3 square. You will already know that. But for random numbers, there is no way you know this information. That is why they are random number. So let's say for this one, if I plot this random numbers, it shows this kind of distribution. In the next one, it changes. See, every time I run it, it creates some new random number, so the plots changes. But what does stay same? The probability of distribution. So the probability of finding a number has some kind of pattern, and that pattern we can find from this histogram. Histogram means you bin the whole range and count how many are there, how many points are there. So these are the bins. So this is data bins and gray. So this looks like a Gaussian distribution. You know what a Gaussian distribution is, right? So Gaussian distribution or normal distribution, it looks like this, right? So it from this binning it looks like. So let's increase the binnings. You see this, and if you increase the random number, the more number you generate, the more prominent this Gaussian becomes. See, I am increasing the numbers, and this Gaussian is becoming more and more like actual Gaussian. That is that's because if you have multiple numbers, you see the probability converges to a particular value very easily. See, for 10 random numbers, it does not show any Gaussian pattern. It shows the equal probability, only 10. But if you increase this, you see, okay, I have increased it too much. Okay, you get it. The beautiful Gaussian distribution. Okay, next is scatter plot. So you can have scatter plots. Let's say you have x random numbers, y random numbers. You want to scatter plot x and y. This is how you can do the syntax is plt.scatter. One very famous thing is pie charts. So you have some kind of levels, and every level had assigned sizes. So how big it is. So you can do this plt.pie sizes and levels, and you can add colors to it. So gold, yellow, green, blah blah blah. These are colors. So A15 will be gold. A15 will be gold, like this. Plus triangle. So these are how you want to show it. So like if you remove this, you see it does not write anything here. So to write the values here, you want this, and if you remove this, it shifts. So these are some extra examples of what you can do more. So you add a title, which is, and that's it. Lastly, let's say you want to save a figure. So let's say you have created, so np.linspace, look up what linspace does. It is very important. plt.linspace, instead of now specifying x like we were doing earlier, we were doing x like this, and here we are doing x like this, and np.linspace and np.sinx. So y will be a sin x. So this is a sine function. X axis, y axis 0 to, let's say 10, till 0 to 10. Plot 10 is like around 3 pi. So, and now you have to plt.savefig sine wave.png. So you can save this figure at some name. Now you see this has been saved, and it is a png file. Now you can use it in some other places, just the plot. So this was the basics of so this was basics of matplotlib and numpy. So now using these concepts, we will try to solve a proper differential equation and try to see what Turing pattern is. So I'll share these two and also the final Turing pattern code also. What the hell? Hi. Okay, NumPy. So this one is for NumPy and this one is for Matplotlib. So this is done. Now we'll solve a PDE and reaction diffusion equation. Okay, so next thing what we will do is try to solve a differential equation using Python and whatever we have learned till now. Like we will use NumPy information, Matplotlib information to plot it, and also some concepts of differential equation solving, which we already have discussed in the last session. So these are the two differential equation. Hold on, I will show it. So these are the two differential equations which are called coupled PD. PD means partial differential equation. What do you mean partial? So it involves partial derivative. So this u and v are actually function of x, y and t. v is also a function of x, y and t. So it in a 2D domain defined by grids, there will be values at every grid points. There will be values at every grid points of this u and v, and they will follow these equations, and we will try to predict what is the value after we solve this equation. So for the details of this equation, you have to go through the last week 7 lectures, I think, and also in the main lectures there he has the Professor Chaitanya Athale has also discussed Turing patterns. So if you go to Turing patterns, you can see that. So I will use this as an example to how to use Python for real problems and how to solve this. So the main, this operator, you see Laplacian u, it actually means partial derivative of u with x, the second partial derivative, plus second partial derivative of v with x, and del u del t is just partial derivative of u with respect to time. And so this is called diffusion. This part is called diffusion equation, and with this part, this extra part, you see, this is called the reaction part. So these are the diffusion part and these are the reaction part. Together they call reaction, diffusion equation. So we will write this in discretized form. Discretized form means so that we can solve this numerically. We are not trying to solve this analytically like in literature people solve it analytically, but here we will solve it numerically. So how to solve this numerically, I will briefly explain. So if you have a derivative, time derivative du dt, there is this sorry. So if you have a time derivative, let's say you have a function f that depends on time and you want to do derivative. So in discretized form and in Euler method, you write this as f of t at some future time, which is delta t ahead of this time t, is equal to function value at this time plus let's say df dt is equal some g t, it equals some other function. So you write it as g delta t times g of t. So df dt, this is definition, like you can think of it like this. You write it f of t plus delta t from the very definition. This is delta t tends to 0. So this is the definition of derivative, which is equals g of t. Now you can put it like from here, from this line you can actually have this. So this is called discretization. This is called discretization of the differential equation. Now if you do it in a loop, what happened? So if you do it in a loop, eventually if you can loop, eventually you can find all the possible all the values at future times of this function. Now in the same way you can actually discretize this Laplacian operator. So what this actually means is, let's say in space, in a 2D grid point setup, this this u and v we are trying to solve is defined on grids, right? Let me make the grids first. So at every grid point, so this is x direction, this is y direction, so every grid point have some values, and the grid spacing is delta x in x direction, delta y in y direction. Now del square f, let's say x y del x square, this will be written in a discretized form as this big thing, which is u x plus del x comma y plus u x minus del x comma y. So once you take two derivatives in this direction, minus u x comma y 2 u x comma y plus u x comma y plus del y plus u x comma y minus del y minus 2 u x y by delta x times delta y, like we have written for the time thing. So this you do twice and you will eventually come up with this kind of equation. Now this along with this del u del t will solve it. So in Python, how we will solve it? First let's import numpy and matplotlib as we have always done. Next is we are size of the grid. So this 2D grid, this whole length of this 2D grid will be, let's say, Lx by Ly. So we need to specify this as 128. So let's Nx means we have 1 2 3 4 5 6. So here we have 6 grid points in x direction, 1 2 3 4 5 6 7 8 grid points in y direction. So these are Nx and y. So if you say length and number, so Lx will be Nx times delta x. So number of grid times grid spacing, it gives you the length of the whole grid, which we would not need much. So in y direction also we take 128 grid only, and dx it's our choice. So we specify it as 2 by nx. So you remember delta t should be small, so delta t is going to 0 here. So very small, we should take all this delta x and delta t will be small. And there is one more criteria, which is delta t by delta x square should be less than half or something, which has to be maintained. The reason I will not going in here. And t is the total time step, so how long you want to see the nature of the system, and number of time iteration is n. So total time divided by dt and with an integerized form. So if you do this int thing, you will get whatever the fraction value is here, that thing's integerized version you will get in n. Now if you go back to your equations, this du, dv and k, these three are your parameters. These are constant. So we will specify this constant like this. These are some motivations which are out of scope of this discussion. You can look up Turing patterns or go to the lectures to how to get this kind of values and what will happen if we change these values. You can play around with this codes and to see what will happen. Now you have to initialize. So you need to have some initial value of u of xt and v of xt at those grids. So these grids will have some kind of initial value. From there we will get some kind of final value after solution, something. So for initial value we are taking random. You remember random between 0 to 1 of the size nx comma ny. V also we are taking random with size nx comma ny. Now to calculate the Laplacian we are defining this function. What it does is it takes f z as a integer, so z can be u, v or anything you want, and it essentially calculates this thing. So u x plus del x y, so it is the one step top, one step towards right, x minus del x is the left. Like if you come back here, you see if you are here, this will be x plus del x with everything else same. This will be x minus del x with everything same. This will be x comma y plus del y. This will be x comma y minus del y, and this will be x comma y. Now so x plus del x, x minus del x, x comma y plus del y, x comma y minus del y, and 4uxy. So this function actually does that only. So for any given z, it returns x plus del x comma y, x comma minus del x comma y, x comma y minus del y, x comma top is top and bottom are the y plus del y, y minus del y, left is x minus del x, right is x plus del x, minus center is the x comma y by dx square. You remember we had delta x delta y, and we have delta x equals delta y, so it becomes delta x square. Now we are defining a function which is called show patterns. It is just to show the 2D grid, and imshow. So this imshow is a matplotlib information which shows the 2D grids. Now this is where we are actually solving. So you see this I in range n is the number of time points. Now if you go from like you are trying to loop around, so remember we have already said that so we have already said to do it in a loop. So do this whole thing in a loop. So that loop is this for loop. So it does it multiple times. So first you calculate delta u, which is this Laplacian u, this function you call, and delta v you have already. You see, take the values inside the grid. So if you come back here, now only for these values we will evolve, and use some other color. Okay, so these are the inside values. For this we will evolve the matrix, and for the boundary values we have some fixed given boundary conditions. For the boundary values we have some fixed given boundary conditions. So these boundary conditions are here, so which are like 0 comma all is 1 comma all, and so this essentially says that derivatives at the edges are 0. So this is the boundary condition. Okay, now this line you see, this line says u equals, this is a little complicatedly written in one line, you can break it down. So what is happening is u equals uc, which is the internal value, plus dt star. So you remember dt star whatever is in the right hand side, so dt delta t, so delta t star whatever is in the right hand side, right? So if you have df dt equals something in the right hand side, you write is f of t plus delta t equals f of t plus whatever is the right hand side. So in our case the right hand side is this whole thing. right? So that is exactly what is happening. UC plus dt star whatever is in the right hand side. What is in the right hand side? Du, the constant, times delta u, which is the Laplacian u, plus uc minus uc cube minus vc, which is this u minus u cube minus vc plus k. And for vc also you are actually doing the same thing. Okay, now when you are doing it in this loop, you get after the at the end of this loop, and also after implying the boundary condition, you get the final result. After this loop ends, you get in u, in this array z, for z in u comma v, so in this array z you essentially get the the updated values of u and v. Now here we are plotting it for the 9 time steps, so different time steps. So you see that t equals 0, this u and v are the yellows and greens are well mixed, so they are have random values. There is no specific value or patterns forming, but after the time evolves, you see eventually some specific kind of patterns coming out. So this was the result of Turing's work, where he said that if you have two competing concentrations or two competing functions like this, and depending on these coefficients, you instead of homogeneous mixing like this, you will see some inhomogeneous pattern. And these are in theoretical biology, these are very important because people use this to understand the mechanism behind some patterns formings in the skin or in any kind of biological system where there are two different kind of concentrations are competing. So to use this, you just run it and you will see. Sorry, what have I done? Okay, sorry, I haven't run a lot of things. That is why it says I have to run everything one by one, so that it takes the section. And yes, now to change, let's say I have changed this k plus to minus. Let's say what happens. Yes, see, it everything has changed. So very early stage it reaches the pattern and it stays like that. So, and let's say from 10 to the power minus 4 to 10 to the power minus 1 I have changed this. What will it happen here? Oh, sorry, you have to initialize everything, and it does not change. Okay, so it going to nan, I guess. I think it is going to nan. So that is the idea. So you can play around with this. You initialize it, then you solve it, and you see you get back the patterns. So you can have more refined data by increasing this from 120 to, so it will take more time, and also you can increase this to 15 times step, so for more time you can have it. Let's run everything here. What we will do is I will try to plot for subplot for 15, and it will take some more amount of time. So it's still running, it will take some time. Oh, it's taking a lot of time. Let's just stop this. Let's go back to whatever we had. T was something like this, 128, and reload this page. Okay. So one by one I'll run everything one more time, and blah 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 blah. Let's see, it should come faster than okay, so that will be all. I'll try to I'll share this all these three things with you in via the meet. Okay, thank you.